The Big Bang wasn't the beginning of the universe. At least, not in the way we've always been told. Because the truth is, the Big Bang Theory, the one plastered all over textbooks and documentaries, doesn't actually explain how the universe started. It skips the most important part, why it happened at all. We're told everything came from a single point, a singularity, and just exploded. But that's not an explanation. That's a placeholder. Here's the controversial part. What if the Big Bang wasn't a beginning, but the aftermath of something else? What if it was an exit? Not an explosion from nowhere, but an eruption out of somewhere. Some physicists now believe the Big Bang might have been a white hole, the theoretical opposite of a black hole. A cosmic outburst where matter and energy are spewed out, but nothing can go in. A one-way door, not into destruction, but into creation. And if that's true, then everything we know, galaxies, stars, time itself, might have spilled out of a dying universe on the other side of that door. That would mean our universe isn't the start of anything. It's just part of something bigger, much bigger. And we might not be the first, not even close. Okay, so imagine this. Everything we know, the stars, galaxies, time, space, you watching this right now, all of it came from a single, massive explosion. That's what we've been told. The Big Bang. The moment when the universe supposedly popped into existence out of nowhere. Just boom, game on. But here's where things get weird. What if that nowhere wasn't nowhere at all? What if that explosion wasn't the beginning, but the aftermath of something else? Something collapsing, something dying, something on the other side of reality. Some physicists are now seriously asking, what if the Big Bang was actually a white hole? Yeah, a white hole. Not some made-up thing from a sci-fi movie. A real object predicted by the same math that gives us black holes. Except instead of pulling stuff in, a white hole pushes everything out. And once you hear how closely this lines up with what we see in the universe, the heat, the expansion, the direction of time, you might start seeing the Big Bang in a completely different way. This theory doesn't just rewrite our origin story, it connects us to something far older, far stranger, and maybe even to something before the beginning of time. Let's break it all down. Because if this idea holds up, then we're not the start of the story. We're just the middle of something way bigger. What the Big Bang Theory doesn't tell us. Yeah, I know. The idea that the universe exploded out of something like a white hole sounds insane. But let's not get ahead of ourselves. First, we need to talk about the Big Bang itself, and more specifically, what it doesn't explain. See, for decades, the Big Bang Theory has been our best shot at answering the biggest question ever. Where did everything come from? The story goes like this. The entire universe started as a tiny, hot, dense point. And then, boom, it expanded. Fast. Space stretched out, galaxies formed, stars were born and died, planets showed up, and eventually, we got to sit here and ask these questions. Pretty satisfying, right? Except, not really. Because if you start poking around in the details, things start falling apart, like, what actually caused the Big Bang? The theory doesn't say, it just starts the clock at universe begins. But why did it begin? What triggered it? Did something exist before it? Or did it just pop into existence from literally nothing? And here's a bigger issue. The theory depends on something called a singularity. That's a fancy way of saying a point where the math stops working. At the very beginning, according to this model, everything in the universe was squished into a spot with infinite density and zero volume. But how can something have infinite density? How can there be a place where the rules of physics, the ones that work everywhere else, just break? It's basically a placeholder for we don't know. And then there's the weirdness of the universe itself. Why is it so smooth? Like the temperature and density across the universe are nearly identical in all directions. But how did that happen if those regions were never in contact? There hasn't been enough time for light, or anything, to travel between them. That's called the horizon problem. And don't forget the flatness problem. The shape of space isn't curved or warped. It's almost perfectly flat, too flat, as if someone calibrated it with extreme precision from the very start. Why? How? To deal with this, scientists came up with cosmic inflation, a rapid burst of expansion just after the Big Bang. And while that helps explain a few things, it also raises new questions. What started the inflation? What stopped it? Why was it so perfectly timed? Are we solving mysteries by adding more mysteries? That's the real problem with the Big Bang theory. It answers what happened next really well. But when it comes to why did it happen at all, it goes completely silent. What actually is a white hole? Let's start with something simple, but wild. We've all heard of black holes, giant cosmic traps that suck in anything nearby. Light, matter, time itself. Once you're in, you're done. No way out. It's like the universe pulled the ultimate no refunds policy. But what if there was something opposite? That's where white holes come in. Now, I know, white holes sound like the kind of thing someone made up just to balance out the black ones. But they're not just science fiction. In fact, they fall right out of the same math that gave us black holes in the first place. Literally the same equations. So if black holes are real, and we know they are, then white holes aren't just imaginary. They're mathematically possible. The universe allows them. It just doesn't seem to use them. At least not in a way we've ever seen. So what exactly is a white hole? Think of a black hole as a place where space and time collapse inward. Everything, matter, energy, even light, gets dragged into a central point called a singularity. And once it's past the event horizon, there's no coming back. The gravitational pull is so strong, escape becomes impossible. That's why black holes are black. Light literally can't escape them. Now flip that idea on its head. A white hole is a region of space where, instead of everything being pulled in, everything is violently pushed out. It's a kind of cosmic explosion in reverse. Not only can you not go inside a white hole, you can't even get close to one. Try to approach, and you'll just get shoved away by the sheer force of space itself. That same event horizon you see around a black hole, in a white hole it works the other way. Nothing can enter it. Everything only moves away. Imagine standing near one. From a distance, it might just look like a burst of light and matter pouring endlessly from nowhere. But as you try to move closer, space itself bends and warps, forcing you back. The laws of physics, the very shape of space-time, won't let you in. All you can do is watch the show. It's a weird concept, right? And it gets weirder. Because in the equations of general relativity, Einstein's great gift to physics, white holes don't need to be invented, they're already there. When scientists first worked out the math for black holes, they found something strange. If you extend those solutions back in time, reverse the clock, a white hole pops out naturally. It's like the black hole has a time reverse twin built into the math. That's kind of mind-blowing. We think of time as having one direction, forward, cause, then effect. You drop a glass, it breaks. The pieces don't jump back together. But the math behind general relativity doesn't care about that. It works the same forwards and backwards, and in a backwards running version of a black hole, what you get is a white hole. So where are they? That's the frustrating part. As far as we know, we've never seen a white hole. No telescope, no space probe, no gravitational wave detector has ever picked up anything we can clearly point to and say, yep, that's one of those cosmic reverse geysers we were expecting. Black holes? Tons. We've even photographed one, but white holes? Zero. There are a few reasons why that might be. The biggest one is stability. The math says white holes can exist, but also that they're incredibly fragile, like absurdly so. The moment something even tiny, like a stray particle or a bit of radiation, touches the event horizon, the entire structure might collapse. That makes them almost impossible to form in nature. at least in the chaotic universe we live in. It's like trying to keep a house of cards standing during an earthquake. Still, some scientists think that a white hole has existed, at least once. You might have heard of it. It's called the Big Bang. That's right. Some theories suggest that the Big Bang was a white hole event. Instead of being the start of everything, it could have been the outflow of something else. Maybe a black hole in another universe collapsed, and all that matter exploded out here as our universe. That idea has serious physics behind it, and we'll get into it later, but it all starts with this one concept. White holes, though elusive, aren't fantasy. They're built into our best understanding of how gravity works. And once you accept that they're possible, everything changes. Because if white holes can exist, even just for a brief moment, they might explain some of the biggest questions we have about the Big Bang, about black holes, about what came before our universe, or if before even makes sense. The truth is, we're still trying to figure out whether white holes are just weird math quirks or hidden parts of the universe we haven't learned how to see yet. But they're not nonsense. They're not random guesses. They're real solutions to real equations. And if one of them exploded into existence 13.8 billion years ago, well, you and I might be part of what came out. The weird connection between black holes and white holes. Black holes are terrifying. They're the ultimate trap in the universe. Anything that falls in, whether it's light, matter, even time, doesn't come back out. Once you cross that invisible boundary called the event horizon, you're gone. No return. Not even information can escape according to what most scientists believe. But there's something strange about how black holes are described in Einstein's equations. The math doesn't stop at just swallowing things. If you take those same equations and look at them from another angle, they reveal something unexpected. A mirror image. A reversed version. A thing called a white hole. Now here's where it gets really interesting. White holes are the theoretical opposite of black holes. Instead of sucking everything in, they do the opposite. They only push stuff out. Imagine an object that you literally cannot enter. You can't even touch it. If you try to approach, the force pushing things away gets stronger the closer you get. And instead of keeping light trapped inside, a white hole is constantly ejecting energy and matter outward. It sounds wild, and it is. But this isn't science fiction. This actually comes straight from Einstein's general relativity. It's just not something we see in nature. At least not yet. See, when scientists first worked out the math for black holes, they found that the equations had two solutions. One described what we know, a black hole. Something forms from a collapsing star, crushes matter down, creates a singularity, and traps everything inside. But if you take those same equations and run time in reverse, you get a white hole. In other words, a black hole looks like matter collapsing into an infinitely small point. A white hole looks like matter exploding out from an infinitely small point. One sucks in, the other spits out. It's like hitting rewind on the universe. That's where the idea of a mirror twin comes from. If you reverse the arrow of time, which in relativity you can do, black holes become white holes. They're two versions of the same thing, just flipped in direction. Same gravity, same space-time geometry, just reversed flow. Now here's the real mind-bender. What if they're not just mathematical opposites? What if black holes and white holes are physically connected? Some physicists think that might actually be the case. Imagine falling into a black hole in one universe and getting blasted out of a white hole in another. That connection, the tunnel between, is what we call a wormhole. Technically, in relativity, it's called an Einstein-Rosen bridge. It links a black hole and a white hole in a single elegant structure. One end draws things in. The other spits them out. This is more than just a cool sci-fi idea. The wormhole is actually a solution to the equations of general relativity. If you extend the Schwarzschild solution, the math behind a non-rotating black hole, to its maximum, the structure naturally includes four regions: our universe, the black hole, the white hole, and another universe on the far side. No extra physics needed. It just falls out of the equations. So in theory, a black hole and a white hole could be two ends of the same cosmic tunnel. What goes into the black hole could come out the white hole, somewhere else in space, in time, or in an entirely different universe. Now, of course, this idea comes with a mountain of problems. For starters, no one has ever seen a white hole. We've seen black holes, lots of them. We've even imaged one. But white holes? Nada, zero. There's no observational proof they exist. Not a flash of radiation, not a weird gravitational ripple, nothing. Part of the reason could be that white holes are incredibly unstable. The math says that if even the tiniest bit of matter touches a white hole's event horizon, the whole structure might collapse. It's like trying to build a sandcastle in a hurricane. It just doesn't last. Another issue is time. For a white hole to exist in the same way as a black hole, it would have to have been there since the beginning of the universe. It can't form the way a black hole does, from a collapsing star. Instead, a white hole would have to exist eternally, ejecting matter from its core forever, or at least since the start of time. And that raises a strange possibility. What if the only white hole that's ever existed, or ever could exist, was the Big Bang? Think about it. The Big Bang was a single point, a moment where space and time seemed to explode outward from a hot, dense singularity. It wasn't a slow process. It was fast, violent, everything rushing out in all directions. That sounds a lot like how a white hole would behave. So now imagine this. In some other universe, a black hole collapses. Inside, the matter gets crushed down beyond our understanding. And then, at some quantum tipping point, it bounces. Not in its own universe, but out into ours, through a white hole. That white hole is the Big Bang, the start of our universe. We wouldn't be looking at the beginning of everything. We'd be looking at the aftermath of something else's end. It's a bold idea, but it explains a lot. Like why the universe started in such a hot, dense state, or why time seems to flow in one direction, or why space is expanding outward from a single point. It also means black holes could be more than just cosmic garbage disposals. They could be gateways, seeds. Maybe every black hole in our universe is creating a new universe somewhere else, blasting out as a white hole on the other side. Maybe we're not at the edge of knowledge. Maybe we're just on the wrong side of the tunnel. The wormhole bridge theory. Here's where things start to get really fun. And kind of wild. Some scientists think that black holes and white holes might actually be connected. Like, literally. Not just in theory, not just in math, but in a real, physical way. And the tunnel that links them? That might be a wormhole. A shortcut through space-time. Now, wormholes sound like science fiction. And yeah, they are used a lot in sci-fi. Spaceships zipping through them, hopping between galaxies, skipping billions of light years in seconds. But the thing is, wormholes aren't made-up fantasy. They actually come straight out of Einstein's general theory of relativity. The math allows for them. They're a real solution to Einstein's field equations. Here's how it works, kind of. Imagine space and time aren't just empty nothingness. They're a fabric. We call it space-time. If that fabric gets bent, twisted, or folded in just the right way, two distant points could actually be connected. It's like folding a piece of paper and punching a hole through it. What was once a long journey across the page becomes just a quick jump through the shortcut. That's the basic idea of a wormhole. Now here's the twist, literally. Some of these wormholes might form from black holes and white holes working as two ends of the same tunnel. One side, the black hole, pulls matter in. The other side, the white hole, blasts it back out. So what if, and this is what some physicists are seriously thinking about, the Big Bang was actually that white hole? Not a magical explosion from nothing, but the other end of a cosmic tunnel that started in another universe entirely. Let that sink in for a second. Everything we know, every planet, every galaxy, every atom in your body, may have come through something. Not just appeared, not started from a single, mysterious point of infinite density, but emerged from the inside of a black hole in some parent universe, like water through a pipe. and exploded into our own universe as a white hole. That explosion would be what we see as the Big Bang. It's not just poetic. The physics actually allows for this kind of thing. Under certain conditions, of course. This idea comes from a specific solution in relativity called the Einstein-Rosen bridge. You might have heard that term before. It's basically the fancy name for a certain type of wormhole that connects two regions of space-time. Einstein himself worked on this idea, along with physicist Nathan Rosen, back in the 1930s. They were trying to figure out what would happen if you extended the math of a black hole fully. What they found was that instead of just leading to a dead-end singularity, the math actually produced a bridge. And at the other end of that bridge was something that looked like a white hole. So technically, when you solve Einstein's equations for a black hole and keep extending them, the math starts to build a tunnel. And that tunnel leads somewhere. Another point in our universe? A different universe entirely? That's where things get fuzzy and exciting. Here's what makes this even cooler. Black holes have something called an event horizon. Once you cross it, there's no going back. It's like a point of no return. But with a wormhole connected to a white hole on the other side, the stuff that falls in doesn't just stay trapped, it goes through. It gets launched out the other end, violently, fast, chaotic, like a detonation, like a big bang. It's a bit like this. Picture a bathtub drain. The water spirals in, disappears. But imagine instead of going to the plumbing, that water gets shot out of a faucet in another room. To the person in that other room, it just looks like water coming out of nowhere. But we know where it came from. It fell in on the other side. That's the wormhole idea. Black hole on one end, white hole on the other. And maybe that's how universes are born. Now, obviously, this is a very tricky thing to study. We can't exactly drop a camera into a black hole and see where it ends up. And wormholes, if they exist, probably aren't stable. The math suggests they'd collapse almost instantly without some kind of weird matter to hold them open. Something with negative energy. We've never seen that stuff for real, but quantum physics hints it could exist in very tiny amounts. Still, some researchers think it's possible, under very extreme conditions, that a wormhole could form and stay open just long enough. Long enough for something to pass through? Maybe not a spaceship, but maybe a universe? That's why some cosmologists are looking again at the Big Bang and asking, was this a wormhole exit? Is our universe just one massive white hole explosion coming from the other side of a black hole in a completely different universe? And if that's true, if wormholes really do act as bridges between universes, then we may not be the first chapter of reality. We might just be a page in the middle. And here's the fun part. If this theory holds, it means we could be living in a multiverse where black holes don't just destroy things, they create things. Each black hole in our universe could be the start of another universe. And we might be living inside a universe that came from someone else's black hole, someone else's death, gave us life. No explosions from nothing, no mysteries with no cause, just a cosmic tunnel, connecting endings to beginnings, and that changes everything. What if our universe came out of a white hole? Think about this for a second. What if the Big Bang wasn't the beginning? Not in the way we've been told. What if, instead of everything suddenly popping into existence from nothing, our universe was actually the aftermath of something else? Something even bigger, older, and way more mysterious? Now let's connect that idea to something most people have at least heard of: a black hole. We know black holes are these insanely dense regions in space where gravity is so strong that nothing can escape, not even light. Once something crosses the event horizon, it's game over. That stuff's not coming back. But what's inside? That's where it gets weird. According to general relativity, all the matter sucked in gets squeezed into an infinitely small point, a singularity. And time and space basically stop working the way we understand them. Here's the twist. The very same equations that give us black holes also predict something else, their opposite, a white hole. If a black hole is the universe's ultimate inbox, pulling everything in, a white hole is its outbox, spewing stuff out into the cosmos, but never letting anything back in. No entry, only exit. Kind of like a cosmic explosion on loop. Now, so far, white holes are purely theoretical. We've never actually observed one, but the math allows them. So they're not science fiction, they're just science that hasn't been proven yet. And that brings us back to the Big Bang. Let's look at what we do know about the Big Bang. It wasn't a quiet event. It wasn't gentle. It was a mind-bendingly fast expansion from a point of insanely high density and temperature. All of space, not just stuff in space, but actual space itself expanded outward in a flash. Energy, matter, light, and eventually galaxies, stars, and us. Everything. And it wasn't just a big explosion in one spot. It was an explosion of space itself. Every point in the universe expanded from every other point. It wasn't something happening inside the universe. It was the universe happening. That kind of behavior, a sudden release of matter and energy, expanding outward with no apparent source, actually sounds a lot like what a white hole is supposed to do. A white hole doesn't form from a collapsing star the way black holes do. It just appears. It exists. And then it starts blasting stuff out. That's what makes this idea so fascinating. Some physicists think the Big Bang was a white hole, not just something similar to a white hole, literally one. In other words, our entire universe could be the inside of a white hole that didn't open into our universe, but created it. So where did this white hole come from? Well, if you keep following the idea, here's where things get even more mind-blowing. Some theories suggest that a white hole could be linked to a black hole, not in the same place, but through something like a wormhole, a tunnel through space and time. So picture this. In one universe, a black hole forms. Maybe a star collapses. Maybe it's something even bigger. Everything gets pulled into that black hole's core, crushed by gravity beyond anything we can imagine. But instead of ending in total destruction, all that energy and matter doesn't disappear. It moves through the wormhole, and it explodes out on the other side. Not as the same matter, but as the beginning of an entirely new universe. A universe with its own space, its own time, and its own physics. Maybe our universe. It's like a cosmic rebirth. One universe dies in a black hole, and another begins in a white hole. The Big Bang isn't the first page, it's the sequel, or maybe even just another chapter in a never-ending book. Some researchers even think this kind of universe making could be happening all the time, that every black hole might be a kind of portal, a factory, if you will, for making new universes. They call it cosmological natural selection. The idea is that universes that are good at forming black holes might be the ones that keep producing more universes. Over time, the multiverse, and if it exists, starts to favor universes with just the right ingredients for complex structures, maybe even life. But coming back to our own Big Bang, this theory would explain a lot of weird stuff, like why is our universe expanding so fast? Why it started out so hot and dense? Why it appeared to have come from a single point, and yet we can't see anything that caused it. A white hole explanation wraps all of that into one elegant possibility. Of course, it's still just a theory. Nobody's found a white hole yet. Nobody's opened a wormhole and looked through to another universe. But that's not the point. The point is, this idea isn't nonsense. It's a serious possibility based on real physics. And it could be the key to finally answering one of the biggest questions we've ever asked. Where did we come from? Maybe we didn't come from nothing. Maybe we came from somewhere else. And maybe the Big Bang was never the beginning. Maybe it was just the latest explosion in a universe that keeps rewriting itself. Again and again. The cosmic recycling system. Imagine this for a second. What if the universe doesn't begin and end? What if it loops? Not in some metaphorical, poetic way, but for real, physically, scientifically. What if the universe is actually part of a cosmic recycling system, where old universes collapse and give birth to new ones, over and over again, forever? This might sound like some abstract sci-fi idea, but it's something that real physicists and cosmologists have been thinking about. And it could answer one of the biggest questions we've ever asked. Where did all of this come from? Because here's the thing, the Big Bang Theory, while powerful and well-supported, doesn't give us a starting point in the way people assume. It doesn't tell us why the universe exploded into being or what caused that moment of expansion. It just says, at time zero, there was an extremely hot, dense state. And then, boom, everything expanded from there. But what came before that? The standard answer has always been nothing. Literally, nothing. No space, no time, no matter, not even the laws of physics. But that answer, if we're honest, doesn't really sit right. Not for scientists and not for most people either. Because it's not really an answer. It's just a placeholder. A question mark we pretend isn't there. Now imagine if instead of starting from nothing, our universe started from something. Not just any something, but the end of a previous universe. That's the core idea behind the cosmic recycling theory. Here's how it works. In our universe today, we know that black holes exist. We've seen their effects. We've even photographed one. That iconic, blurry, orange-ringed image of a black hole at the center of a distant galaxy. Black holes are real. They're out there, swallowing stars, warping time, bending space. They're extreme, but they're not rare. In fact, they might be more common than we think. And we also know that black holes trap everything that falls into them. Matter, light, information, gone. Once you pass that boundary called the event horizon, you're not coming back. Not in our universe, at least. But now flip that idea on its head. If a black hole is a place where everything goes in, what if there's a place where everything comes out? That's the idea behind a white hole. A theoretical object that's basically the reverse of a black hole. Instead of pulling things in, it pushes things out. You can't enter it. You can't touch it. All you can do is watch as it explodes with energy and matter. And here's where things get wild. Some physicists think that a black hole in one universe might actually create a white hole in another. In other words, the stuff falling into a black hole here could be blasting out into a new universe somewhere else. Now stay with me, because this is where it gets really interesting. If that's true, then every black hole could be a kind of cosmic portal, a gateway to a brand new universe. And when a black hole collapses, the singularity at its center, that mysterious point of infinite density, could actually be the start of a new Big Bang, a white hole, a new cosmos, expanding into its own version of space and time. So instead of the universe having a beginning and an end, it has cycles, endless loops, a kind of cosmic rebirth system. Think of it like this. A universe is born, it grows, it expands, it forms galaxies and stars and planets and black holes. Eventually, it ages. Maybe it keeps expanding until it cools down into nothingness, or maybe the expansion slows, and gravity pulls everything back inward. In either case, those black holes that form during its lifetime keep growing, swallowing more and more, and eventually, they reach some tipping point. The material inside gets crushed so tightly, under so much pressure, that something's got to give. The rules of physics, or at least the rules as we currently understand them, break down. But instead of collapsing into nothing, something happens. The black hole flips, and from that collapse, a white hole emerges. Somewhere else. Maybe even someone else. And that explosion becomes a new universe. That explosion is what we saw as our Big Bang. And if that's true, if our Big Bang was actually the death of a previous universe, then the cycle just keeps going. One universe births the next, over and over again. That's the cosmic recycling system. Now let's be clear, this isn't just poetic speculation. There are real scientific models exploring these ideas. For example, some theories in quantum gravity, like loop quantum cosmology, suggest that the universe never actually reaches infinite density. Instead, as it collapses, quantum effects kick in and create a kind of bounce. The bounce avoids the singularity, It prevents the math from going to infinity. And that bounce? That's the Big Bang. Or at least what we call it. But in this case, it's not the beginning of time. It's just the rebound of something older. Other models, like those based on string theory, suggest the universe might go through phases: expansion, contraction, rebirth. Imagine an elastic universe that stretches, snaps back, and stretches again. Forever. And it's not just theoretical math that points this way. Some scientists have looked at the properties of our universe, the way matter is spread out, the uniform temperature of space, the incredibly fine-tuned laws of physics, and said, this looks like something that inherited conditions from something else. Like how children inherit features from their parents, maybe our universe inherited properties from a previous one. If true, this would also explain something really puzzling. Why is our universe so good at making black holes? Think about it. Our universe seems almost designed to form black holes. Stars are the perfect size. Galaxies clump just the right way. Gravity behaves just right. And if black holes are what give rise to new universes, then maybe there's a kind of natural selection going on. Universes that are good at making black holes make more offspring. Universes that aren't fade away. It's cosmic evolution. But instead of survival of the fittest creatures, it's survival of the fittest universes. Over time, more and more universes emerge from black holes, each one slightly different, but only the ones that are good at creating more black holes, and therefore more universes, continue the cycle. And that could explain why our universe works the way it does. Not because it was designed, not because it was random, but because it's part of a chain of universes that gradually adapted to be good at reproducing. It's the biggest recycling program imaginable. And here's the beautiful part. This idea doesn't throw out the Big Bang. It doesn't say it didn't happen. It just says the Big Bang wasn't the start of everything. It was the start of us, the start of this chapter, this cosmic round. But before us, there was something else, a universe before ours. Maybe many. We don't know what that universe looked like. It might have been totally alien. Different laws, different forces, different forms of matter, or it might have been eerily familiar with galaxies, stars, and even life. We might never know. But we might be able to see echoes, fingerprints, left behind in the fabric of our universe. Strange alignments in the cosmic background radiation. Tiny clues in the way the universe is structured. We're just starting to look. And if we ever find real evidence, just one piece of proof that suggests a previous universe existed before our Big Bang, then we'll know we're not the first. We're not the only. We're just part of a much bigger pattern. That's the cosmic recycling system. It means the universe isn't a straight line from nothing to something. It's not a one-time firework that pops and fades away. It's a loop, a pulse, a breath, expand, collapse, rebirth, over and over, forever. Is Big Bang a white hole? Let's talk about one of the weirdest, boldest, and honestly most fascinating ideas in modern cosmology. The possibility that the Big Bang wasn't the beginning of the universe, but the end of something else. That it might have actually been a white hole. Now, if you've never heard of white holes before, you're not alone. They sound like something straight out of a sci-fi movie. And in a way, they kind of are. But here's the twist. White holes aren't just made-up stuff. They're real solutions in Einstein's theory of general relativity. The same math that predicts black holes also says white holes should exist. And if that's true, it opens the door to one of the craziest possibilities ever proposed. That our entire universe was born not from nothing, but from a white hole eruption in another universe. Let's take a step back for a second. We all grew up hearing about the Big Bang. This idea that the universe started as a tiny, hot, dense point, and then exploded outward, expanding and cooling to eventually become everything we see around us. Galaxies, stars, planets, you, me, all of it came from that moment. The Big Bang has been the backbone of modern cosmology for almost a century, and it works really well. It explains a lot of what we observe, the way galaxies are moving apart, The faint afterglow of that first burst of light we see as the cosmic microwave background, even the abundance of hydrogen and helium in the universe. It's a solid theory, but there's one thing the Big Bang doesn't explain. One big thing. It doesn't tell us what caused the bang. It just describes what happened after. It picks up the story once the explosion is already happening, not what lit the fuse. And when you follow the math all the way back, it takes you to this nasty place called a singularity, a point of infinite density and zero volume, where all the known laws of physics completely fall apart. It's a dead end, a cosmic shrug. And that's where white holes come in. So here's the basic idea. A black hole is a region of space where gravity has become so strong that nothing, not even light, can escape it. It pulls everything in and holds it forever. But when physicists looked at the equations for black holes and extended them backward in time, kind of like rewinding a tape, something strange popped out. A white hole. A white hole is like a black hole in reverse. Instead of pulling everything in, it only pushes things out. You can't enter it. You can't even get close. Matter and energy are constantly flying out, but nothing can go in. It's a one-way door, but facing outward. And here's the thing. The structure of the equations doesn't just allow for white holes. It demands them. If black holes are possible, and we know they are because we've seen them, then white holes are also possible, at least on paper. They're like the time-reverse twin of black holes. So what does that have to do with the Big Bang? Well, think about what the early universe looked like. A moment of extreme energy, an explosion that flung matter and light in every direction, space itself expanding faster than the speed of light, all from a single point. Doesn't that sound exactly like a white hole? Some physicists started wondering, what if the Big Bang wasn't just similar to a white hole, but actually was one? What if what we see as the beginning of the universe is really the end of something else? The output of a black hole from a previous cosmos? Imagine a universe collapsing into a massive black hole, all the matter and energy it ever contained getting sucked into a dense singularity. But instead of staying trapped forever, it tunnels through a kind of bridge in what physicists call a wormhole and explodes out the other side as a white hole. That eruption? That could be our Big Bang. Suddenly, instead of a universe that came from nothing, we're looking at a universe that came from somewhere. The death of one universe gives birth to the next, and instead of one isolated Big Bang, we now have a chain, maybe even an infinite cycle, of universes being born and dying over and over, connected by black holes and white holes. Now you might be thinking, okay, that's a cool story, but is there any reason to think it's true? Fair question. The answer is, maybe. There are a few things about our universe that make more sense if it started as a white hole. For one, the uniformity of the cosmic microwave background, that soft glow of heat left over from the early universe, is almost too perfect. Regions of space that are now billions of light years apart somehow ended up at the same temperature, even though they were never in contact. That's known as the horizon problem. Some scientists think that if our universe came out of a white hole from a single, ultra-dense point, then that kind of uniformity would be a natural outcome. There's also the flatness problem. The fact that the universe seems to be incredibly flat, not curved like a ball or warped like a saddle. Again, that's hard to explain under the traditional Big Bang model, but it could be a natural feature of space expanding out of a white hole. And then there's the idea that black holes could be like seeds. In some models, every black hole could give rise to a new universe inside. That means our universe might have started inside a black hole, and now we're just living in its internal expansion. From the outside, that black hole might still be sitting somewhere in another universe, completely unaware that it contains us. Of course, there are problems with this theory too. White holes, as cool as they are, have never been observed. We've seen black holes, lots of them. We've even imaged one directly. But white holes? Nothing. Not even a hint. Part of that might be because they're super unstable. In most versions of the math, white holes can't survive any interaction at all. If a single photon, just one, gets too close, it can disrupt the whole thing and cause it to collapse. That makes them incredibly hard to detect, and maybe impossible to sustain for more than a fraction of a second. But maybe that's all it takes. Maybe the Big Bang was that one, perfect, one-time white hole. A burst so fast and so massive that it didn't need to stick around. It exploded, expanded, and became the universe. And then it was gone. Another challenge is the direction of time. White holes mess with what we think of as the flow of time. They reverse entropy, the natural increase of disorder. And that's something we've never seen happen. It's like watching a broken glass reassemble and fly back onto a table. But maybe, just maybe, in the very early universe, when quantum rules were king and the usual laws didn't apply, something like that could happen. It's also possible that the white hole idea doesn't need to be a permanent structure. Some models suggest that the Big Bang was a temporary white hole, a brief moment of reversal where space and time opened up from another state of existence. It doesn't need to last forever. It just needs to start everything. At the end of the day, we don't have all the answers. And that's okay. That's what makes this fun. But what we do know is this: the equations of physics don't rule out white holes, and they don't rule out the possibility that the Big Bang came from something else, something before. Maybe the Big Bang wasn't the beginning. Maybe it was the middle. And maybe somewhere out there, another universe is collapsing and getting ready to give birth to the next. So why don't we see white holes everywhere? So here's the thing that confuses a lot of people. If white holes are real, and if they're written into the very same equations that describe black holes, then where the heck are they? Like seriously, why don't we see them all over the universe? We've spotted black holes. We've even taken pictures of them. That blurry glowing donut thing? That was a black hole's shadow. We can detect their gravitational pull, watch how they mess with nearby stars, and even hear them when they collide, thanks to gravitational wave detectors. They're very much real, very much present, and very much active. But white holes? Nothing. Zilch. Not a single confirmed sighting, and that's weird, right? Well, maybe not. White holes might not be around because they just can't survive. Like, literally. They're too unstable to even exist in the kind of messy, chaotic universe we live in. They're theoretical ghosts, written into the math, but not showing up in the sky. Let's break it down. Imagine a white hole floating in space, not some explosion like the Big Bang, just a regular old white hole sitting there. Now here's the weird part. Unlike a black hole, which pulls things in and never lets them out, a white hole does the opposite. It keeps pushing things out, forever, and it doesn't let anything in, at all. Not light, not particles, not even a breeze of cosmic dust. Nothing. It's like a one-way valve that only spits stuff out but slams shut if anything tries to enter. Now that sounds pretty wild already, but here's the problem. Our universe isn't empty. It's full of stuff. Light, radiation, particles, atoms, magnetic fields. It's busy out there. Even in deep space, you're surrounded by cosmic microwave background radiation, random hydrogen atoms, high-energy particles zipping around, and the occasional rogue photon. So imagine this. A white hole appears somewhere out in the void. Instantly, it's met with something. Maybe a particle that just happened to be flying by. Maybe a soft wave of radiation. Doesn't really matter what. All it takes is one tiny interaction, one bump. And just like that, the white hole falls apart. Because it turns out white holes are incredibly sensitive. Even the smallest disturbance can throw off the delicate balance they need to exist. If a single piece of matter or energy tries to enter, which again the universe is full of, it breaks the rules of the white hole. And the equations say, nope, can't happen. So instead of gracefully dealing with it, the white hole collapses or mutates into something else entirely. Probably into a black hole, if anything. So really, white holes aren't like black holes at all. Black holes are stable. They form when stars collapse, and once they're born, they're nearly impossible to destroy. You can feed them matter, surround them with dust, even collide them with other black holes, and they just grow bigger and stronger. But white holes? They're the cosmic equivalent of a soap bubble in a thunderstorm. Beautiful in theory, but the moment something touches them, pop. This is why we don't see white holes everywhere. They're not invisible, they're impossible, at least in the world we live in today. There's just too much noise, too much interaction, too much going on for them to survive. You could almost think of them like hypothetical fossils from another age of the universe. Maybe they could exist in a more pristine, untouched version of the cosmos, maybe right at the beginning, during the earliest fractions of a second, when space was still smooth, empty, and quiet. A white hole could form. One big one violent, one-time eruption, one Big Bang. That's one of the reasons some physicists think we've already seen a white hole, and we called it the birth of the universe. But as for little white holes floating around today, dropping bits of matter into space like cosmic vending machines, not going to happen. They wouldn't last long enough to be photographed. They wouldn't even last long enough to be noticed. They'd collapse before we could blink. Now here's another twist. In theory, there could be tiny white holes, like quantum-scale white holes, that pop in and out of existence faster than we can detect. Sort of like particles that flicker in and out of the quantum vacuum. These might exist technically, but again, they wouldn't last long, and they wouldn't produce enough energy or radiation to show up in our instruments. It'd be like trying to detect a single firefly blinking once in the middle of the sun. There have also been theories, and I mean really speculative ones, that maybe some of the strange, sudden bursts of energy we detect in deep space are white holes. Fast radio bursts, gamma ray flashes, that kind of thing. But so far, none of those signals look like what we'd expect from a white hole. They're short, but they don't match the energy pattern. Plus, there are better explanations for those events, like magnetars or neutron star collisions. So the white hole idea is kind of the last resort theory. It's worth pointing out, though, and this is important, the fact that we haven't seen a white hole doesn't mean they aren't real. We hadn't seen black holes for decades either. We just saw what they did, the way they bent light, the way they pulled stars around them like they were toys. White holes might be the same. Maybe we're looking in the wrong way. Maybe the one we did see was the Big Bang itself. Maybe white holes don't appear randomly. Maybe they only show up at very specific moments, under very specific conditions, at the birth of a new universe. And if that's true, then of course we don't see them everywhere. They don't happen in this universe. They happen between universes. So yeah, white holes are real, in the math. But the universe we live in, it's just not a good home for them. There's too much light, too much energy, too many particles floating around. There's too much stuff. A white hole needs a quiet universe. Ours is loud. So the next time someone asks why we haven't spotted any white holes yet, here's what you can tell them. It's not that we aren't looking. It's that by the time we look, they're already gone. Here's the twist. Maybe we did see a white hole, just once. And that was the Big Bang. Think about it. Everything we know about white holes says they should be wild, violent, and ridiculously short-lived. They're not the kind of objects that quietly hang out in space. They're dramatic. And if one did exist, it wouldn't just gently release matter into the universe. It would explode with unimaginable energy, space, and time itself. Sound familiar? That's basically how we describe the Big Bang. It wasn't just a big boom in space. It was space. Space expanding. Time beginning. Matter being flung outward in every direction. Energy that was so intense, so dense, that even the laws of physics took a second to catch up. In a lot of ways, it lines up perfectly with what a white hole should look like. One massive outpouring of everything with no warning, no source, and no way to trace it back to anything we can see. And then, it vanished. Not the universe, that's still here, obviously, but the moment, the singularity, the actual white hole, if that's what it was. It came and went in an instant, leaving behind everything we see today: galaxies, stars, planets, black holes, people, pets, microwaves, all of it. But the white hole itself, gone. like a match that flared up and burned out, lighting everything else in the process. There's no leftover shell, no aftershock, no visible mark in the sky. The only thing we have is the cosmic microwave background, that faint glow left over from the very early universe. It's like the final whisper of that explosion, still echoing faintly across the cosmos. And to this day, we're trying to decode it, pixel by pixel, hoping it'll tell us more about what that first moment really was. So maybe the reason we don't see white holes now is simple. We've already seen the biggest one we're ever going to see. It didn't look like a hole in space. It was space, expanding, stretching, cooling, becoming. And if that's true, then we're not just floating in a universe that had a beginning. We're living inside the result of a one-time cosmic escape hatch. The only known white hole in history. And everything we know, everything we are, it all came pouring out of it. White holes as universe starters. So here's a pretty wild idea. What if black holes aren't just where things end, but where things begin? I mean, we've been told for years that black holes are these terrifying cosmic death traps, places where stars go to die, where space gets torn apart, where time stretches out and nothing ever escapes. Not even light. And yeah, all that's true. Once something falls into a black hole, it's gone. Lost beyond the event horizon. Forever out of reach. But here's the twist. Some physicists think the story doesn't end there. In fact, they think that black holes might be more than just endpoints. They might be bridges, or better yet, birthing rooms. Think about this. Inside every black hole is a singularity. A point where gravity crushes matter down to a space smaller than an atom. A place where density becomes infinite, and our physics completely breaks down. It's like hitting the edge of a map that just says, "Here be dragons." Now, if you're a scientist, that's incredibly frustrating. You don't just want to know that something's gone, you want to know where it went, what it became, and what happens next. Here's where it gets really interesting. Some researchers believe that the singularity inside a black hole might not be a dead end at all. Instead, it could be a kind of cosmic pressure cooker. Imagine all that matter, stars, gas, planets, maybe even light and information, getting crushed into an unbelievably tiny point. Now, if the universe hates infinities, and the math says it does, something has to give. That energy can't just sit there forever. So what if, and this is the big what if, all of that matter doesn't vanish? It bounces? Not inside our universe, not somewhere we could ever see, but into a completely new one. In this view, every black hole isn't just a pit, it's a tunnel. And on the other side of that tunnel, a white hole, a place where all that crushed matter gets blasted back out, starting fresh, starting a universe. Yeah, a whole universe, with its own space, its own time, its own physics. A brand new cosmic bubble inflating outward, just like ours did. And here's the kicker. Maybe that's exactly what our universe is. Maybe our Big Bang wasn't the start of everything, just the start of this version of everything. Maybe it was the outflow of a white hole in some other universe, a universe that collapsed, formed black holes. And one of those holes became the explosion that gave rise to us. It sounds like sci-fi, but this idea actually fits with some real math. There are models in physics, serious ones backed by solid equations, that say black holes can tunnel into new universes. And the thing they tunnel through? That's the white hole. That's the burst on the other side. In these models, time keeps going. The old universe collapses, but the singularity isn't the end. It's a gateway. It explodes into a new region of space-time that's completely disconnected from the original. That means we'd never see the old universe. We'd have no idea it existed, but we'd still carry the fingerprints. In the way our universe expanded, in the patterns of the cosmic microwave background, in the very laws of physics we experience every day. Some theories go even further and say this is happening constantly, that every black hole, everywhere in our universe, is giving birth to baby universes, tiny ones. Universes that bud off and grow completely separate from ours. We wouldn't be able to see them, They'd be causally disconnected, but they'd be out there. And each one might have slightly different physics, different gravity, different chemistry, maybe even different kinds of life. In fact, there's a theory that takes this idea and turns it into a kind of cosmic evolution. It goes like this. The universes that are better at forming black holes produce more offspring. More black holes equals more baby universes. Over time, universes that are better at black hole production become more common. And since black holes need stars to form and stars need stable matter, maybe this whole process explains why our universe seems so perfectly set up for life. It's not luck, it's selection. We live in a universe that can form stars, which form black holes, which form new universes. And that cycle just keeps going, kind of like natural selection, but on a multiverse scale. Only the most fertile universes, the ones good at making black holes, get to reproduce. This flips the whole idea of our universe being fine-tuned for life on its head. It's not that the universe was made for us. It's that universes like ours are the ones that survive because they're good at making more universes. And we just happen to be in one of them. Now, is there proof for any of this? Number not yet. These are ideas. Bold, creative, deeply mathematical ideas. But they're not made up. They come from real attempts to answer the questions that the standard Big Bang model doesn't. What caused it? What came before? Why do our laws of physics work so well? Why do black holes even exist? And most importantly, are we alone in the cosmic family tree? If every black hole spawns a universe, then there could be an unthinkably huge network of realities out there. A branching structure of universes, each one born from the death of another. Some would be stillborn, others would flourish. Some would collapse back into black holes of their own, starting the whole process again. Maybe black holes are the seeds, not of destruction but of creation. And maybe, just maybe, the next time a massive star dies and collapses under its own gravity, it's not ending its story. It's beginning a new one, somewhere far away in a universe we'll never see. Maybe the next Big Bang isn't in our future, but in someone else's beginning. The multiverse breeding ground. Now we're heading into deep, weird, brain-bending territory. But hang in there, because this is where the Big Bang theory starts connecting to something way bigger. And I don't just mean bigger in size, I mean bigger in possibility. Because if the Big Bang was actually the explosion of a white hole, and that white hole came from a black hole in some other universe, then yeah, we might be living in something way more vast than we imagined. We might be living in a multiverse. Let's break that down. A multiverse is exactly what it sounds like. Not just one universe, but many. Maybe even an infinite number of them. And here's the crazy part. Each universe in this multiverse could have its own laws of physics, its own ingredients, its own versions of stars, particles, even time. And we might be inside just one tiny bubble. Now, this isn't just random sci-fi speculation. This idea actually comes straight out of very real physics, from the exact same equations that gave us black holes and the Big Bang in the first place. The more we try to understand how our universe began, the more we bump into this strange, almost inescapable idea that maybe, just maybe, this place we call the universe is just one of countless others. And what links them all together are black holes and white holes. So let's rewind a bit. Imagine a black hole forming in some old universe. A giant star collapses. Gravity takes over. The whole thing gets crushed into a single point. And then, in our current understanding, it's game over. Matter disappears into the singularity and nothing comes out. But remember what we said earlier. Singularities are just a fancy way of saying, our math stops working here. It's not necessarily the end. It's the edge of our knowledge. But what if, instead of ending, that matter gets funneled through something? What if, deep inside that black hole, there's a bounce, a flip, and everything that falls in gets blasted out the other side? That other side might be a white hole. And if that white hole expands fast enough, gets big enough, and lasts long enough, you get a universe. just like ours. That would mean our Big Bang, this huge universe-launching explosion, wasn't the beginning of everything. It was just a transition, a transfer, a handoff from one reality to the next. One universe dies, another begins. It's not creation from nothing. It's creation from somewhere else. Now here's where it gets wild. If every black hole can eventually become a white hole, and every white hole can become a new universe, then every universe can give birth to more universes. Universes giving birth to other universes. It's like cosmic reproduction. But instead of DNA and cells, it's gravity and space-time doing the work. So instead of one universe with one beginning, we now have a never-ending branching tree, a giant, infinite network of universes, each sprouting from black holes, each expanding into their own realities. Some of them might be tiny, some might be short-lived, some might never develop stars or galaxies, others might last billions of years just like ours, and that's where we come in. See, our universe has some pretty weird features. It's almost suspiciously well-balanced for life. The forces of nature are just strong enough, but not too strong. Atoms hold together, stars burn steadily, planets form, water exists, life evolves. If any one of these things were even a little bit different, none of this, including you watching this video, would be possible. Scientists call this fine-tuning, and it's one of the biggest mysteries in cosmology. Why does the universe seem so perfectly set up for complexity and for life? Now, if there's only one universe, this fine-tuning is just odd. It's a cosmic coincidence, like rolling a trillion dice and having them all land on 6. But if there's a multiverse, if there are trillions of universes being born all the time, then it makes more sense. Most of those universes wouldn't be right for life. They'd be too chaotic, too dense, too fast, too cold. But eventually, one of them, maybe by pure chance, would land on the right combination. That's the one that makes stars, galaxies, planets, oceans, trees, brains, and YouTube. That's our universe. From this view, we're not lucky. We're just one of the few places where the conditions happen to be right. We live in the Goldilocks universe, not too hot, not too cold, just right. And the only reason we're able to notice it is because we're here. It's a powerful idea. And the white hole theory gives it a kind of cosmic logic. If black holes spawn white holes, and white holes start new universes, then each universe might tweak the rules just a little. The laws of physics change slightly with each generation. Some universes survive and grow, others collapse. Over time, this becomes a kind of natural selection on a cosmic scale. Imagine a universe that produces more black holes than others. That means it produces more baby universes, which means its offspring become more common in the multiverse. Over billions of generations, you'd get universes that are better and better at making more universes. That includes universes like ours, with the perfect balance of ingredients to form stars, black holes, and eventually life. This is sometimes called cosmological evolution, like Darwin's theory, but for entire universes instead of animals. And the white hole idea might be the missing link that makes it all work. Of course, there's one huge catch. We can't see these other universes. Not yet, anyway. If a white hole created our universe, then the connection, the wormhole or tunnel or whatever it was, is long gone. The moment our universe started expanding, it broke away, like a bubble snapping off from a bigger bubble and drifting into its own world. That means we can't send signals back. We can't peek through. We're locked inside. But that doesn't mean we're clueless. Scientists are still looking for indirect signs. Tiny fluctuations in the cosmic microwave background, the leftover heat from the Big Bang, could hint at strange interactions in the very early universe. Unusual patterns, energy imbalances, or unexplained cold spots could be evidence of something else, something before the Big Bang. And if we ever find signs that don't match what we'd expect from a simple one-universe model, the multiverse theory might become more than just speculation. Even without direct proof, the multiverse helps explain some of the biggest questions we have. Why does the universe look the way it does? Why do physical constants seem so precise? Why does anything exist at all? It's a weird answer, but it might be the most honest one. Maybe we're not the main show. Maybe we're not the only universe. Maybe we're not even a particularly special one. Maybe we're just one of an infinite number, lucky enough to be stable, balanced, and old enough for life to happen. And maybe that's enough, because even if we can't see those other universes, even if we can never visit them, the fact that they might exist changes how we see our own. We're not at the center of the cosmos. We're not the first. We're part of a chain, a ripple, a branching story that goes far beyond what we can observe. And all of it might have started inside a black hole. The physics of the impossible. Let's be honest, this kind of stuff sounds like science fiction, right? The idea that the Big Bang might have been a white hole, that our entire universe could have been blasted out of the other end of a black hole from somewhere else? At first glance, it sounds totally insane. But here's the thing. In physics, impossible doesn't always mean wrong. It usually just means we don't get it yet. That's the fun part about science. It's full of things that used to sound impossible until we figured them out. Once upon a time, people thought it was impossible for the Earth to orbit the sun. Then it was impossible for humans to fly. Then splitting the atom was impossible. Even black holes, those cosmic monsters we now study using real data, used to be nothing more than a weird math result buried deep in Einstein's equations. People thought they were too strange to be real. Now, we've actually taken pictures of them. So when people say white holes can't be real, it's worth asking, are we sure? Or are we just not ready yet? Here's what we do know. White holes aren't just a random invention. They're not made-up sci-fi concepts. They actually come from the same set of equations that predict black holes, Einstein's general theory of relativity. Those equations are like a playbook for gravity. They describe how massive objects bend space and time, how matter moves, how light curves, and how the universe evolves on the biggest scales. And when you run those equations all the way, they don't just give you black holes. They give you white holes too. It's like solving a math problem and getting two answers. We've seen one of them in the real universe, black holes. But what about the other one? What if we've already seen the white hole too, but we didn't recognize it? Now think about what the Big Bang looked like. According to our best models, the universe started off as an incredibly dense, hot point, not just filled with matter, but filled with energy. Then, all at once, it began to expand. Space itself stretched. Time began. Matter and radiation exploded outward, and the universe as we know it began to take shape. If that doesn't sound like a white hole, I don't know what does. White holes, on paper, do exactly that. They explode outwards. They eject matter and energy. Nothing can go in, only out. That's what makes them the opposite of black holes. And when you compare that to what the early universe was doing, well, the similarities are hard to ignore. The reason we don't just jump up and declare the Big Bang was a white hole is because we still don't fully understand how it would work in practice. The physics is there in the math, but the real-world part, the part we can observe or measure, is still fuzzy. That's not because the idea is bad. It's because we don't yet have a complete theory that combines everything. General relativity, which is great at describing big stuff like stars and galaxies, and quantum mechanics, which is great at tiny particles and energy. Right now, they don't play nicely together. And where they clash? You guessed it, the beginning of the universe. That's where the white hole idea might help. If we can figure out how to blend quantum physics with general relativity, something physicists call quantum gravity, then maybe white holes stop being hypothetical and start being real. A proper theory of quantum gravity could explain how something incredibly dense and energetic could explode into a full-sized universe without needing infinite density or breaking the laws of physics. Right now, we have ideas, like string theory and loop quantum gravity, that are trying to bridge that gap. Loop quantum gravity, for example, replaces smooth spacetime with tiny loops of energy. In this model, When things get too dense, instead of collapsing into an infinite singularity, they bounce. Boom. No infinity, no breakdown, just a bounce. A white hole could be that bounce in action, but until we can prove it, or at least test it, we're in that weird space between crazy idea and potential breakthrough, which, by the way, is exactly where most scientific revolutions begin. And honestly, a lot of the resistance to the white hole idea comes down to mindset. We're used to thinking of black holes as the ultimate end. You fall in, you're gone. Game over. But what if that's not the end? What if it's a doorway? What if black holes are more like cosmic seeds, gathering material, compressing it, and then, in some distant region of space or time, releasing it in a white hole event that kickstarts a whole new universe? That's not fantasy. That's real physics being explored in academic papers and high-level research right now. Is it proven? Not yet. But neither were black holes, until the evidence piled up. Look, science is a work in progress. It's not about locking in answers and never changing them. It's about staying curious and following the evidence, even if it leads to weird places. So maybe the Big Bang being a white hole is one of those weird places. But so was quantum mechanics. So was dark matter. So were gravitational waves. All of them sounded impossible at some point, until they weren't. So instead of asking, is it too weird to be true? Maybe we should be asking, is it too weird to ignore? Because in space, weird is normal. And the more we learn, the more we realize. The universe doesn't really care what we think is possible. It just is. The Big Bang without a singularity. Here's where a lot of people get tripped up. And honestly, it's not their fault. The word singularity gets thrown around so much in space documentaries and science books, but what it really means is a bit of a mess. Technically, a singularity is just a point in space and time where the math breaks. It's not just really big or really small. It's undefined. Infinite heat, infinite density, zero size, and more importantly, zero explanation. But that's the thing. When something goes infinite in physics, it usually means one thing: our math has stopped working. It's a sign that we've hit a wall in our understanding, like trying to divide by zero on a calculator. It just doesn't compute. So when we say the universe began from a singularity, we're not really saying we understand what happened. We're saying that our current theories don't have the tools to describe it properly. So what if there was no singularity at all? More and more physicists are starting to think that the Big Bang wasn't the absolute beginning of everything. It wasn't a magical moment where everything came from nothing in a single pop. Instead, it might have been a kind of transition, a phase shift, from something else that came before, something that didn't break the laws of physics, something that didn't go infinite. Let's try thinking of the early universe not as a singular point, but as an incredibly small, incredibly hot state. Still mind-blowingly extreme. We're talking trillions of degrees and densities way beyond what we see in stars or black holes. But not infinite, just maximum. A kind of cosmic pressure cooker where everything was crammed into a space smaller than an atom, but still real, still physical, still describable with the right tools. This is where ideas like the bounce come in. Instead of the universe springing out of nowhere, maybe it was collapsing before it expanded. Imagine a previous universe, maybe one a lot like ours, slowly contracting under gravity. Stars collapsing, galaxies shrinking, space itself getting tighter. And then, instead of collapsing into a singularity, it hits a limit, a point where gravity gets countered by something else, maybe quantum pressure or some kind of twist in space-time we don't fully understand yet. And then, bounce. That collapsing universe doesn't end. It flips, it rebounds. And that rebound? That could be our Big Bang. Not a beginning, but a continuation. A handoff from one cosmic era to the next. This idea isn't just wishful thinking. It's backed by some serious physics. In general relativity, when the equations lead to a singularity, it's a sign that relativity alone isn't enough. You need quantum physics to step in. And that's exactly what a lot of modern theories are trying to do. Merge the smooth curves of Einstein's spacetime with the jittery, unpredictable rules of quantum mechanics. One of those attempts is loop quantum gravity. It's a theory that says space isn't smooth like a sheet. It's made up of tiny loops of information, kind of like the pixels on a screen. And in this model, the universe can't shrink smaller than a certain point. Once it reaches that minimum size, it naturally bounces back. No singularity, just a really intense squeeze, followed by a release. There's also the idea that torsion, a kind of twisting of space, could create enough pressure to stop the collapse before it hits infinite density. Think of it like the universe twisting itself so tightly it pushes back out. Again, no singularity, just a turnaround. And here's why this matters. A bounce model could fix some of the biggest problems in cosmology, like the flatness problem, why space isn't curved, or the horizon problem, why distant parts of the universe look almost exactly the same, even though they've never had time to communicate. If the universe had a previous phase, it could have had plenty of time to smooth itself out before bouncing into our current state. Now, does this mean we can say for sure that the singularity never happened? Not quite. We're still working with theories and mathematical models. We don't have direct evidence yet. But here's the thing. We never had evidence for the singularity either. That was just where the math took us, because we were only using half the story. The exciting part is that we're finally starting to see the other half. The Big Bang might not be the edge of a cliff where time drops into nothingness. It might be more like a bridge, a narrow, fiery, violent bridge, connecting whatever came before to what we see now. And if that's true, then the universe isn't a one-time event. It's part of a cycle, a heartbeat, an eternal rhythm of collapse and rebound. No singularity, just transformation. And somehow that's way more poetic, because it means we're not just a lucky accident that popped out of nowhere. We're part of something deeper, something older, something ongoing. And the more we look into it, the more it starts to make sense. Black holes, endings or beginnings? We've always seen black holes as the final chapter, the place where everything goes to die. Stars collapse, light disappears, and matter vanishes forever. Once something crosses that invisible line, the event horizon, there's no coming back. Not for light, not for time, not even for information. It's like the universe's ultimate delete button. That's how black holes have been portrayed for decades. A one-way street to nowhere. The end of physics as we know it. But what if that's not true? What if we've been thinking about black holes all wrong? What if, instead of being the universe's graveyards, they're actually its nurseries? What if black holes aren't where the story ends, but where the next story begins? This might sound like sci-fi, but physicists are starting to ask the same thing, because here's the twist. The math behind black holes, the equations from general relativity, doesn't just stop at the event horizon. It keeps going. And when you follow that math through, something really strange happens. You get a white hole. That's right. The opposite of a black hole. Something that doesn't pull stuff in, but pushes it out. Something you can't enter, only exit. A white hole isn't just a theoretical twin. It might be what's on the other side of a black hole. Now here's where it gets wild. Some scientists believe that when a black hole forms, the matter inside doesn't get crushed into a single point forever. Instead, it gets compacted down to a super dense state. And then at some point, it could bounce back. That bounce, according to some models, might be a white hole. Not here in our universe, but somewhere else. That means a black hole here could actually be the beginning of a new universe somewhere else. Let that sink in for a second. You fall into a black hole, or more realistically, a star does. All its particles, energy, and information get sucked past the event horizon, and instead of ending in oblivion, it reaches a kind of limit. Then, it explodes outward in a completely different space-time. On the other side, that explosion might look exactly like what we call the Big Bang. So now we're looking at black holes not as cosmic ends, but as gateways. Gateways to new universes. And this isn't just fantasy. Some serious physics backs it up. For starters, singularities. The core of a black hole where everything supposedly collapses into infinity are more like red flags in math. They're signs that our equations are breaking. not necessarily that nature itself breaks. Many physicists believe that if we had a full theory of quantum gravity, that singularity would disappear. Instead of infinity, you'd get something super dense, but finite. And from that, a rebound is possible. This leads to what's called a bounce cosmology. Basically, something contracts, like in a black hole, and then bounces back in an expansion, like a white hole, or maybe even a Big Bang. And if you follow this logic, every black hole could be the seed of a baby universe, including the one we're in right now. It's like cosmic recycling on the biggest scale imaginable. Think about how many black holes exist in our universe. Millions, probably billions. Some are as small as a city, others bigger than entire solar systems. If each one is spawning a new universe, then the multiverse might not just be a possibility, it could be a never-ending, ever-growing tree of reality. Each branch starting with a black hole, exploding into a new white hole, and forming a new universe with its own rules, its own time, maybe even its own version of physics. And maybe that's how we got here. Maybe the Big Bang wasn't the beginning of everything. Maybe it was just a white hole, the outflow from a black hole that formed in some ancient, unreachable cosmos. That would make our universe the child of another one. And maybe someday the black holes inside our universe will do the same, giving birth to more universes after us. It completely flips the narrative. Instead of thinking of black holes as cold, dead endings, we start to see them as fertile beginnings. Not just places where matter disappears, but where entire realities might be born. Of course, this idea is still speculative. We don't have a way to peer inside a black hole, and we've never observed a white hole in the wild, but the math doesn't say no. In fact, it says maybe. And in physics, maybe is often where the biggest discoveries start. Black holes are still terrifying. They bend space, stretch time, and erase anything that gets too close. But now, they might also be the most creative objects in the universe, literally crafting new universes out of their own collapse. So maybe we need to stop thinking of black holes as the end of the story, because in reality, they could be chapter 1. Well, we're not at the beginning. We're in the middle. And this is the biggest idea of all. Maybe the universe didn't begin with us. Maybe we're just one chapter in a much longer story. A story with no first page. A universe that keeps going and going and going, building itself from its own collapse. The Big Bang wasn't the start, it was the continuation. That idea might sound huge, overwhelming even, because for so long, we've treated the Big Bang like the ultimate origin, the first domino in the chain, the moment when time, space, and matter all switched on. But if it turns out the Big Bang was just a transition, not a beginning, but a bounce from something else, then everything shifts. Suddenly, we're not the first. We're not the main act. We're one thread in a giant cosmic fabric that might stretch infinitely forward and infinitely backward. Universes expanding, collapsing, bouncing, and repeating, like cosmic breath, in and out, in and out. And if black holes really do spawn white holes, if universes can come from universes, then maybe nothing ever truly begins or ends. Maybe there's always something before, and always something after. That would mean time, at least in the biggest sense, doesn't have a start or a finish. It loops, it folds, it stretches, and we here on our little blue planet are living right in the middle of it all. Think about how much that changes the way we look at our existence. We often ask, why are we here? Or, how did everything start? But maybe the better question is, what part of the story are we in? Because maybe it's not about a single moment of creation. Maybe it's about being part of a much larger cycle, a universe that gives birth to itself over and over again. That could explain why the laws of physics are so balanced, why the conditions were so perfect for stars, planets, and life to eventually form. Maybe it's not just luck. Maybe it's the result of billions of cosmic cycles, trial and error on a scale we can barely imagine. Universes trying out different settings until one finally sticks. And maybe ours is one of those. But here's the part that makes your head spin. If we're in the middle of a much bigger cycle, What comes next? What happens when our universe grows old? When the stars burn out and galaxies drift apart? Do we collapse back into black holes, setting the stage for the next bounce? Is someone else out there, far in the future, going to look back at us the way we look back at the Big Bang? Not as the beginning, but as just another ripple in the timeline? We may never have the full answer. But just asking these questions puts us in a different mindset. We stop thinking of ourselves as the center, and we start seeing ourselves as part of something far, far bigger. We're not at the start. We're right in the middle of the grandest mystery there is. And that is kind of beautiful. So where does all of this leave us? Well, we started with the Big Bang, the grand explosion that supposedly marked the beginning of everything: time, space, matter, energy, all packed into a single point that blew outward and became the universe we live in today. And that model? It works. It explains a lot. Why galaxies are flying away from each other, why we see a faint afterglow across the sky, the cosmic microwave background, why the earliest elements formed the way they did. But here's the thing. It doesn't explain what came before that. It doesn't tell us why the bang happened, or what caused that tiny hot point to even exist in the first place. It just starts. That's where white holes come in. White holes are like black holes flipped inside out. Instead of pulling everything in, they push everything out. Nothing can get in. They only explode outward. And the crazy part? Some physicists now believe that the Big Bang might have been exactly that, a white hole. Not the start of everything, but the exit of something else. Think of it like this. A black hole forms in one universe, collapsing under its own gravity, packing everything into a tight, unimaginably dense point. And at the other end of that collapse, boom, a white hole. A brand new universe blasts into being, not from nothing, but from something else. Our universe. And that opens the door to a completely different way of thinking. Maybe the Big Bang wasn't the beginning of all things. Maybe it was just the latest chapter. Maybe we are living in a cosmos that recycles itself endlessly, through black holes and white holes, through collapse and expansion. A universe that doesn't start or end. It cycles. That means our universe might not be alone. In fact, there could be countless others. Universes that came before us, and others that will come after. Some similar, some wildly different, some with their own versions of physics, particles, or maybe even intelligent life asking the same questions we're asking right now. And what about black holes? Those terrifying monsters lurking in the centers of galaxies? Maybe they're not just cosmic shredders. Maybe they're portals, gateways. Maybe they're seeding the next generation of universes right now. Every time one forms, it could be creating a new reality on the other side. What looks like death here could be birth somewhere else. We don't have solid proof for any of this yet. No telescope has ever spotted a white hole. No experiment has tracked a black hole, giving birth to another cosmos. But the equations don't say impossible. They say maybe. And in science, maybe is everything. It's the start of every great discovery. It's the spark behind every mind-blowing theory. It's what keeps physicists up at night, and what makes this whole thing worth exploring. Maybe our entire universe is the echo of a dying star in another world. Maybe we're riding the aftermath of a black hole's collapse, stretching across billions of years. Maybe we're just one thread in a cosmic tapestry that goes on forever. We don't know for sure. But that mystery, that endless horizon of what if, is what makes space so fascinating. The more we learn, the more questions we find. And the deeper we look, the more connected and weird it all starts to seem. So no, maybe the Big Bang wasn't the beginning. Maybe it was a white hole. And maybe we're just now starting to understand what that really means. Subscribe.